So one reaction that occurs in the blast furnace during the extraction of iron is the reaction between iron 3 oxide and carbon. So calculate the relative formula mass of iron 3 oxide using the information from the periodic table. So above in the equation you can find the formula of iron 3 oxide, and it is Fe2O3. So if we look in the periodic table, we can see the relative atomic mass of iron is 56, but we have 2 of them, so that's multiplied by 2. And then we can see the relative atomic mass of oxygen is 16, but we have 3 of them, so that's multiplied by 3. So what we see then is we have 112 plus 48. So 111 plus 48 equals 160, so the relative formula mass is 160. So looking at question B, 320 kilograms of iron 3 oxide were added to the blast furnace. Calculate the amount in moles of iron 3 oxide. So in order to do this one again, now we need to get back to our formula triangles. So the number of moles equals the mass divided by the Mr. Or if you look at the formula triangle and you cover up N for the number of moles, it's mass divided by molar mass, or Mr. Okay, so let's put that information into the equation then. So what is our mass in grams? So looking at the question, we can see that 320 kilograms is our mass. We need to convert that to grams. So 320 times 1,000 will be 120,000. 1, 2, 3, 0. Add on the 3 zeros. Now we'll divide that by our molar mass, which we figured out in the last question, which is 160, and that will give us an answer of 2,000 moles. So again, if you look back at the units, this is in grams per mole, and you can cancel out the units and you end up with units in the end of moles. That's one way of checking if you've done your calculation correctly. So moving on to the next part of the question, it says calculate the maximum amount in moles of iron formed from this amount of iron 3 oxide. So looking back up at our equation, we can see that iron 3 oxide, Fe2O3, plus 3 carbon gives you 2 moles of iron plus 3 moles of carbon monoxide. So if we look for our ratio for what it's asking us in the question, we're looking at iron 3 oxide, and we're also then looking at iron. So there is a 1:2 ratio there. So what that means is 1 mole of iron 3 oxide, will make 2 moles of iron. So we can then write down this ratio, which is 1:2, and then if we then go on, we can see that what the amount of moles of iron 2 oxide that we have from the previous question is 2,000 moles. So 2,000 would be proportional, so we multiply by 2, and for the ratio we'll get 4,000. So the answer is 4,000 moles of iron. So calculate the maximum mass in kilograms of iron that can be formed from this amount of iron 3 oxide. So we've already done the hard bit. We've already figured out how many moles of iron we can make. So we need to just convert that moles now into a mass. So we need our formula for this. So our formula is number of moles equals mass divided by Mr. Or again, if you prefer the formula triangle will look like this. So we have mass, number of moles times molar mass. So let's rearrange the equation for what we want. We want mass. So if we want mass equals number of moles multiplied by the Mr. Okay, so on the formula triangle, if you cover over mass, you can see that you just get the bottom section, which is N times molar mass. So now let's shove the information in. So we put down 4,000 because that was our moles from the previous question. We have our Mr. from earlier on as well, which is 56. So in total we get 224,000 grams. 2 and 3 grams. So that is 224 kilograms.